And now let's see the matrix eigenvalue problems. And in this part, we will discuss how can we find the eigenvalues or eigenvectors of a matrix. And then I will extend the idea to generalized eigenvalues and eigenvectors. In mathematics, for matrix A, if there exists a bicolumn vector X, also if there exists a lambda, a number, which makes this equation satisfied, then we call lambda is one of the eigenvalues of the matrix. And for n by n matrix, normally we will have n eigenvalues and n eigenvectors. And how can we find the eigenvalues and eigenvectors? We can use the EIG function. And if you code the function like this, you can find the eigenvalues of A in B. And if you want to find the eigenvectors as well, you can use this function, you use this syntax. And the D should be a diagonal matrix containing all the eigenvalues in the matrix. And V is the eigenvector matrix. And with each column corresponds to an eigenvalue in the matrix. Let's compute the eigenvalues of A, for example. If we code a function like this, we can find all the eigenvalues of A. So these are all the eigenvalues of matrix A. We can find it immediately. And this is the numerical result. There might be errors. If you want to get symbolic result or accurate result, what you need to do is to convert A into symbolic matrix and then call EIG function. And these are the eigenvalues, exact numbers in the eigenvalues. If you are trying to use symbolic form, you can get eigenvalues like this. So this is one way to call the EIG function. If you want to call EIG function in this way, you will get two matrices. The second matrix return contains all the eigenvalues. And for the first matrix, you will find that the first column is the eigenvector corresponding to this eigenvalue. The second column are the eigenvector for this eigenvalue. So we can find all the eigenvalues and the eigenvectors. And it should be noted that the eigenvalue matrices are not unique. For instance, if we multiply this column by 2, it is also an eigenvector. So it may not be unique. And by the use of Matlab function, we will have all these columns normalized, which means that you will take the square values of these terms and add them together, we will get 1. So they are called normalized. So if you use Matlab function EIG, you will get normalized eigenvectors. Even you normalize it, you can also change it as well. If you multiply this part by -1, it is also an eigenvector. So it is still not unique. And the EIG function can also be called in this way. And you can convert A matrix into a symbolic matrix and then take the EIG, and you will find that the second matrix is still an eigenvalue matrix, and this one are eigenvector matrices. However, they are not normalized. So if you use the EIG function, you can find all the eigenvalues and eigenvectors of a given matrix. Now let's consider the other mathematical description like this. And in the standard eigenvalue problems, we do not have B matrix. And here we may consider an even more complicated case where we insert a B there, and B is a symmetrical positive set matrix. And I've explained this one later on. And in this case, lambda is called the generalized eigenvalue of matrix IM. The axis you call the eigenvector of the matrix. How can we find generalized eigenvalues? We can still use the EIG function and put AB in the function called the generalized eigenvalues and eigenvectors. So I am not going into too much detail, mathematical detail about it. So what you need to do is know how to use the EIG function